All right, welcome to Giving Tuesday. Hot, coming out hot here to start the day. My name is Keith Hannon. Welcome to the Boyce Thompson Institute Giving Tuesday Live. I keep wanting to say Giving Day. It's that, but it's really Giving Tuesday. It's a hashtag. It's a whole thing. This is our third year in a row coming to you live from BTI, and we're going to have a full day of researchers and BTI alumni and past faculty members here. It's really a full day of talking scientific research, why it matters, what the impact is, and how you can help us continue to advance the work that we do here at BTI. So you'll see a little graphic at the bottom of your screen. Eventually, it talks about where you can go to support BTI research, and that's btiscience.org/give. That's pretty easy to remember.
I would agree.
Pretty easy to remember. Yeah. So who are the two people next to me, awkwardly sitting here while I introed the day? Well, they are our first guests from BTI's Van Eck Lab, and their names are Kait and Nathan. Kait, Nathan, welcome to Giving Tuesday Live at BTI. Thank you for being the first guest, which is nice because there's no expectation set.
Very true.
You are the opening act, so thanks for getting us all warmed up. So first, maybe just kind of introduce yourself and talk about, what you do here at BTI.
So, as Keith said, I'm Kait. I have worked at BTI for 11 years. I actually just celebrated my 11th anniversary.
Wow, 11 years.
11
That's a good run.
years. It is.
More than a decade.
It's a lucky number.
That's a golden watch, I think.
You know what? I guess the Fitbit will have to do.
That's the modern day golden watch.
It is.
You get a Fitbit.
It is. I started out in the greenhouses right after college. I did a stint as laboratory services supervisor for 3 years, and now I work, as Keith said, in Joyce Van Eck's lab. I'm working on what are called plant transformations. Right now I'm working with maize and grape varieties. I've worked in the past on tomato, potato, ricimum is what I'm working on right now, but basically we're just using natural infection of plant material with what is called agrobacterium, but it's a bacteria that naturally infects the plant, and we insert a gene into the bacteria and then infect the plant with that bacteria, and in order to try and get the gene inserted into the plant material we're interested in, and then get back edited plants. So right now, it's in maize and grape.
Well, that sounds good. We like our grapes around here in the Finger Lakes region, right?
That's exactly why we're working on grapes, actually, is because it's a very important New York State crop. So I am working right now on Merlot and Chardonnay and Riesling. So cold tolerance is one of the genes we're trying to work on, and also powdery mildew resistance, which is unfortunately a very big problem and pervasive problem in grapes. So
if you are a Finger Lakes wine drinker, wine consumer, wine maker, grape grower,
I have a vested interest
this
in
is some work that's very important to you. So right off the bat, I'm going to sell you on wine today, Giving Tuesday. Support wine research because it's big for our economy and it's really good for our palate.
Indeed.
Speaking of good for our palate, Nathan, tell us a little bit about what you do here.
Yeah, so I'm a postdoc in Joyce's lab. I've worked 10 fewer years here than she has. So I joined about a year ago, and I work in gene editing using a wild plant called the Groundcherry to try and using genome editing to domesticate this wild plant. So it's a food crop. You can buy it at the farmer's market, but it's a really unproductive plant that's really like you couldn't just grow it in a farmer's field like you could like corn or wheat. So we're trying to improve the crop and accelerate that improvement rather than traditional breeding that farmers or that breeders have relied on a very slow natural mutation rate. We're speeding that up in order to select for beneficial traits like larger fruits or more compact plants that can be grown in a row cropping system.
Yeah, I think I had not until I became more familiar with your research. I don't think I'd ever heard of the Groundcherry. And then what I like to do is walk around town like I know something about science, right? So I talk about the Groundcherry and some of the stuff we're doing with the Groundcherry. Turns out a lot of people actually know the Groundcherry. It's kind of like this favorite of the, I don't know, I don't want to say foodies, but like the eclectic gardener, maybe?
I think it's also more popular in Europe. It seems
Okay.
like some of my expat friends in Europe know more about Groundcherry. It's
They're always doing things better over there, aren't they? Come on.
They're ahead of the wave. I don't know.
They've been around longer, to be fair.
To be fair, yes. Old world, new world, yes.
Yeah.
So what you're trying to do is essentially make it even more common. Get this thing in grocery stores, make it so we can grow it in more abundance, right? Is that fair?
Exactly, yeah. I mean, even in Europe where it is sort of popular, you still only see it as like a garnish on dishes. You don't, and if you see it at the farmer's market, they're selling it for like $5 a pint because, I mean, there really aren't that many fruits that grow on each plant. So one of our goals is to increase the number of fruits per plant so that farmers growing these can get a better yield. They can sell them for cheaper and maybe make their ways into the supermarket rather than just these specialty farmers markets. Yeah.
So if you like Groundcherry, if you think they're delicious, and they are, if you
They
haven't
are.
had one yet, they are very good.
Taste of pineapple, and it's really
Yeah, I think
delicious.
that's fair.
Yeah.
Yeah.
That's my
Which makes
personal
the
assessment.
cherry part of the name maybe a little misleading. Because
Ground pineapple is kind of a
Ground-
long
yeah.
name.
it's a long
And then you'd
name.
think they were mini pineapples. They look more like cherries.
Right.
Right.
So they are delicious, so keep an eye out for them. And we're going to try to make them more popular, and so you see them more often, and hopefully they become more than just a garnish. They become a whole, we can design a whole entree around the Groundcherry.
That would be nice.
Dessert, could it fit into dessert?
Pies,
Yeah.
Yeah, pies?
absolutely. Yep.
Okay.
The fifth berry, right? That's the goal.
Yeah, so there are four.
The drive for 5.
Yeah.
Okay.
This is a thing among horticulturalists that we have 4 berries that we commonly consume. It's strawberry, blueberry, blackberry, and raspberry, and that for years people have been trying to make the so-called 5th berry. So there have been other fruits that people have been trying to push forward and get people to adopt, but
Boysenberry doesn't
right
come in the top 5?
They're not
No?
technically
Yeah.
berries.
Oh, they're not.
Right? Isn't that? Or no?
Oh, I have no idea. I don't know anything about the boysenberry.
I just remember when I lived in California, it was a popular type of jam. They'd make like boysenberry.
Boysenberry.
Yeah.
Yeah.
But
Okay.
okay, well, we got some work to do on that one too, I guess.
I will have to
So
research.
if you see me kind of looking over here on occasion, it's only because we are streaming live on Facebook and our website. If you have a question, you could throw it in the
Any
feed
questions?
here,
Yeah.
and I'll try to relay it to our guests, assuming it's relevant and in good taste, which it should be, because we're talking a lot about good tastes here
Yes.
early on
That's
in the
right.
morning.
Yes.
I already want to kind of go wine tasting after talking to you all. Not the sign of a
We
problem.
didn't build that
Yeah.
into Giving Tuesdays.
We should have. We should have. Next year for sure. So you're doing a lot of really impressive work and exciting work. Has there been anything kind of new that's come along this year that kind of is a highlight of yours, or has it kind of been just business as usual?
Yeah, so we've been the gene editing technology, CRISPR, you may have heard of it, is still relatively new. So most of what we've used it for is to induce mutations, just like natural mutations occur. One other application for CRISPR is to be able to knock genes into the genome. So say you have a gene that increases nutritional content in a berry, you could potentially put that gene into the Groundcherry to further increase its nutritional content. At this point, that technology is relatively unproven. We're working on that now in order to kind of further the technology. So the application there would be we could well, really do anything. Any gene we want, we could put into the genome at any location that we want. So that's my exciting news.
Yeah, and I think that's something you see around this whole institute is this kind of, for people that aren't as familiar with BTI science, it's a common theme, this push to, take food, essentially crops, and try to make them more nutritious for populations that really need that. A Groundcherry, not so much a staple crop, but similar. I mean, I don't want to sell it short. Maybe it could be. I don't want to hurt its fifth berry campaign here. But we do work with like sweet potato here at BTI, and how millions and millions of people depend on that for daily nutrition, and trying to make that more nutritious in places where it can make it more tolerant and make it so we can grow it in different places. So that really is kind of a common theme. So when we talk about how does BTI support food security or food production, this is kind of one of those ways, kind of what you've been talking about. The Groundcherry is an example of kind of crop improvement here at BTI.
Absolutely, yeah.
So Kait, one thing I like about what Van Eck Lab does is that it's kind of this, it kind of has like a global client base. Is that fair to say? With some of these requests that come in for transformations, can you talk a little bit about that?
I would say so. I mean, I know our coworker Carrie worked on a project called ENSA, and I couldn't tell you right now what ENSA stands for, but
so many acronyms in science. Yeah. Just remember BTI. That's the one of the day. That's the acronym of the day.
And that was a collaboration with the John Innes Center in England. So, and I did work for University of Oxford as well. I've also worked with the university in Australia. But I mean, the need for plant transformation, gene editing of different crops is a global need, like you're saying, and it really is a specialty science. Not many labs are equipped to do tissue culture and plant transformation, so ours is renowned for that, and people know it, and they come to us, and we help them as best we can when we can. So, and different labs have different specialties. So,
yeah, it's a really good point. Our lab is really uniquely positioned because CRISPR is an amazing technology, but you can't do CRISPR if you can't transform the plants. And so our lab is doing both of those. We do transformation, and we also have our CRISPR lab too.
So while we're on the topic, because it might come up throughout the day, does anyone want to take a shot at just a high-level overview of what CRISPR is? Because it's a topic that a lot of people, if you're just reading the news, you probably see it pop up, right? Especially with the new story that just came out of China about CRISPR babies. People are getting scared.
Yes.
We always we like taking the fear out of science here sometimes, right? Yes. So in general, does anyone want to just kind of explain as simply as possible what this technology is?
Yes. So I think I can do that. So CRISPR in and of itself, all that it does is cut DNA at a specific point based on the sequence that you provide it. So if you have a gene and you know the sequence of that gene, you can direct CRISPR to cut at a specific sequence in that gene. That's all that CRISPR does. After it's cut, the cell's own machinery, the DNA repair machinery, then attempts to repair that DNA strand that's been cut. Our cells and plant cells and every other animal cells are really good at repairing DNA. So the DNA will just come back together after it's been cut. Typically then CRISPR cuts that same DNA again. And it does this like thousands of times in the cell. But every once in a while, the cell's machinery makes a mistake, and it will either insert one base pair or remove a base pair. And what that does is it it changes the DNA sequence, and then will change the functionality of that gene. Typically, we refer to it as like a knockout of the gene, meaning that the gene is no longer active at that point. And so that Chinese CRISPR baby that came out like that was yesterday.
Yeah. Very current here.
Yeah.
Giving Tuesday Live. Yes.
Yeah. So I don't know much about viruses, but my understanding is they just knocked out or inactivated a gene that HIV uses to replicate itself. So that's it. That's all CRISPR is you're inducing mutations in whatever gene you're studying.
And the idea is that is beneficial for what you're using it on.
Yeah, in our context, yes. Yeah. There are a lot of researchers that want to inactivate genes to see what they do.
Right.
You know, you can knock out a gene and say, oh, this plant died immediately. This gene must be pretty important.
Right.
Yeah.
Okay. Well, thanks for that overview. Is there anything? Just a couple more questions. Is there anything that you kind of your dream scenario for kind of where your research goes in the future? Like if you kind of had a picture perfect image of in 10, 15 years where your research is at that point, what does that look like?
Well, that's
how much time do we have?
Yeah, it's hard to imagine like 10 to 15 years down.
Or shorter, wherever kind of, or in general, kind of where do you what does it look like where you just go, wow, we really kind of got to where we set out to get?
Yeah.
And then you kind of go from there.
Me personally, my dream is to use gene editing tools to be able to produce new compounds in plants. We call this metabolic engineering. You're literally engineering the metabolism of a plant. For example, this would be useful for producing pharmaceuticals in plants rather than growing them in E. coli in a lab. And also be able to use that to make plants that are more capable of defending themselves against plant pathogens, for example. That would be maybe 10 or 15 years down the road.
Great.
But yeah, with gene editing technology, it's really like the sky is the limit. It's an amazing technology. You can do almost anything you want with it.
Yeah, and it's, when we talk about, it makes me think, when we talk about the Groundcherry becoming more abundant and more available, and that's a great kind of end product for the Groundcherry, but really the research you're doing to get it to that point goes beyond that, right? I mean, because you're learning from the Groundcherry what you may be able to apply to other things.
That's a great point. Yeah, what we've learned here we could apply to other wild species or even domesticated crops that we grow today, to be able to, maybe we'll see in 20 years this plethora of just new crops that we've never eaten before. We could potentially do that. We don't know yet. We'll find out.
We'll find out.
And when did CRISPR even come in? I mean, it was just a few years ago.
I think it was like 2012 that the very first paper came out. And
and
maybe like a couple years later they got it into plants.
So we're still kind of on the burgeoning.
Yeah,
it's very exciting.
How about you, Kait? Any
grand
visions?
What I really am interested in is the gene editing of the grape, because there are certain varieties in the Finger Lakes, for instance.
Wine.
Wine.
Just keep saying wine.
It's too early. But obviously, in our wineries up here and vineyards and whatnot, certain varieties grow better than others, and that tends to be, at this point, colder climate, white varietals, your Rieslings, your Gewürztraminers, your... and then,
That's a tough one. I don't ever pronounce it.
Gewürztraminer.
Yeah, that's really tough. I don't order it because I don't want to mess it
Just
up.
say Gewurz. People will know what you're talking about.
Sorry.
No, that's okay. And over in California, you have your big-bodied reds. They do very well. You're familiar.
I am familiar.
But if you were able to confer cold resistance, you would be able to grow those varieties up here. Much better. I mean, they still are grown here. We have Merlot wines. We have, what they call Meritages up here, which is like a Bordeaux blend.
An occasional Pinot Noir.
An occasional Pinot, yes. But to be able to have that option, that variety, I just think that that's a really exciting progress to be able to make. And that's what I hope to do.
And the Finger Lakes is certainly doing better and better, it seems, in kind of the national wine rankings.
Absolutely.
So, I grew up down in the Binghamton area, and people would go wine touring up here, and I think it was just to do something, right? It wasn't
it's here.
Yeah, I mean, this is late 80s, early 90s. It's not, because wine enthusiast is pumping out these gold medals for the Finger Lakes, right?
It's true, yeah.
And now I feel, but that's changed.
Yeah.
There's a lot of respect for these wineries and these growers. Within a 3-minute walk of my house are 2 different winemakers in the Finger Lakes, so it's great to kind of meet the people. So it's a whole great culture. I'm done. I'm not going to do any more tourism commercials for the Finger Lakes, but it is great to show. I think for people that live around us that might not know a lot about BTI to see what a local impact we have as much as a global impact.
There are real life applications right in our home vicinity.
Yeah.
In beautiful Ithaca, New York.
That's right. My last question for you both is a question everyone will get today, and you are, both deeply committed to your work in science. But when you're not in science, what are you doing? You're not home doing science, right? You have a life. What are some of your hobbies? Some of your passions? As we
You do homebrewing.
hopefully there's some young future scientists watching, and they want to know that you don't have to be a scientist 24 hours a day, right?
True.
You can do
true.
You can do a lot of other things. People here playing bands and
our lab is subterranean, but I do like to see the light.
That's right. You are the Van Eyck lab is in the basement, but every so often they come out.
It works well for my fair skin. I really, really enjoy taking advantage of our natural landscape, hiking and the waterfalls. They're abundant here, absolutely beautiful. I also enjoy playing music. I play the flute. I
didn't know that.
Dabble in the guitar.
Nice.
I dabble.
Great.
I know chords, but it's getting my fingers to do the chords. And
You got to start somewhere.
Yes, exactly. I enjoy trivia.
Yes?
Yes, and now I'm getting into knitting because it's knitting season again. I mean, it could be knitting season all year round, but when it's cold, I like to have something on my lap.
It's comfort food and knitting season. Right?
It is indeed, yes.
Winter has snuck up on us a little earlier, so we really got to get that cold tolerance
It's
going.
True. That's true. Sooner rather than later.
It would be better to have that right around the corner.
Blankets aren't going to cut it for these grapes.
No, we can only have so many Afghans out in the fields.
It's true.
Nathan, how about you?
Yeah, so I got a few hobbies. So I went to school in Iowa, and not to knock Iowa, but there's not a lot of things that aren't cornfields there.
Right. It's known for corn.
Right, yeah. So, when I moved here, like my first, the most exciting thing to me was, there's like 4 state parks within like a 15-minute drive. So I hiked like all summer.
Yeah.
It was amazing. Besides that, I homebrew my own beer.
Yes, that's right. I should have mentioned that earlier.
I enjoy that hobby very much. There's not that many hobbies where you get to eat or drink whatever you've made. So I've got a chocolate porter brewing right now. Hopefully bottling that next week.
We really missed an opportunity to do taste testing during this interview.
Yeah.
Yes, we did.
I know.
Wine, beer.
Who is producing this show? This was a terrible.
Maybe next year a Groundcherry beer.
Yeah, that's what we've been
nice.
talking about is making a Groundcherry beer.
That would
we'll
be
do
great.
it. We'll get it done.
We need to move the alcohol makers to the end of the Giving Tuesday broadcast, so we can toast on a high note at the end of the day.
Yeah.
Oh, well, that's fantastic. Yeah.
Did you say fantastic?
I think
Fantastic.
I think he did. Yeah. Fantastic.
I like it.
Yeah.
Well, thank you so much for both being here and sharing some look at your research and what you do here at BTI. And also, I wanted to mention, congratulations to Nathan, who won our Flash Science competition about a month ago. Are you still basking in that glory?
Oh, yeah.
Do people get
I've
out of
seen
the
the
way
glow,
when
the
you walk
aura
down the
is
hallways?
there.
So this was essentially a type of 3-minute thesis type competition where we had about a dozen researchers here stand up and explain what they do in 3 minutes with really no visuals, and they had to explain it so the most novice science person could understand it. And Nathan was chosen by a panel of 7 judges as the best presenter. So he walked away with a little cash in his pocket. So this holiday season, you know, if Nathan is generous to you, you can thank his hard work probably at Science. But really, thank you both for being here. It's never easy to be the first guests of the morning, but you came anyways, and we really appreciate you being here and everything you're doing for BTI and for the local and greater communities. Your work has remarkable benefits for everyone, so thank you very much. If you want to learn more about the Van Eck Lab, I believe it's btiscience.org/van-eck, I think. Google it, BTI, Boyce Thompson Institute, Joyce Van Eck. You'll get their lab page, you'll see their pictures, and you'll know you're in the right place. Lots to learn about there, and some really exciting work being done. Your lab has been in the New York Times recently, had a big write-up in Wired magazine for some of the work you've been doing. So as someone that tracks those things, I can say the Van Eck Lab has been very much in big news outlets this year in 2018. So big year for Van Eck Lab, big year for Kait and Nathan. So thanks for coming. And we will be back in just a few minutes where we're going to dive into a little bit of the origins and history of BTI and kind of how this place came to be and what we've done over the last 90 plus years of our existence. So come on back. Thank you both, and we'll see you real soon.